Hello everyone, we are HiFlyLabs from Hungary and we are excited to be presenting to you our solution for the churn challenge. Let's kick it off.
So why did we go for churn prediction? Churn modeling is heavily used in online businesses. It can be said that it's become an industry standard. The value of Hacker News is its user base, so it's vital for them to keep the users from churning. A well-tuned churn model helps understand the underlying patterns of churning, identify high-risk churners, and with a sound churn treatment strategy, it can intervene to stop the churn.
If you'd like to talk about churn, we have to agree on the definition first. In order to do that, we looked at the longest time period where each user was inactive. On the right-hand side, you can see a graph where the y-axis shows the longest time period where a user was inactive, and on the y-axis, you can see the ratio of users who were never inactive for a longer time period than which shows on the x-axis. As a churn definition, we picked 30 days of inactivity because, as you can see on the graph, if we choose 30 days, only 12% of the users we classify as churners, who then after returns. On the other hand, 30 days is still a reasonable time period if we would like to analyze our data.
So we decided to collect as much data as possible. We used the Hacker News API. We collected more than 6 million items, covering more than 2 years and getting more than tens of thousands of unique users. We defined our churn, so if someone is active for 3 months but then disappears, then they are a churner. We created 2 different data sets to cross-validate our findings, and we created loads of features to train our models on. We wanted to see how users registering in the same time period behave, and we chose a cohort, people registering in 2019 February. Basically, their activities show stability over time, and their churn ratios are also around 20% every month, which is a class imbalance, moderate class imbalance, but it's stable over time. And we were presented with the usual problem in machine learning. We applied 2 models, one highly accurate random forest and one less accurate logistic regression. We went with the logistic regression because of the business use case. Logistic regression has most important features, their signs, their coefficients, and marginal effects.
To evaluate the predicting performance of our model, we introduced the terms of ROC curve and measure AUC. As you can see, our model did pretty well. Almost 80% of the cases are predicted correctly by our logistic regression. This performance is more accurate than usual churn prediction cases. And one should focus on the false negatives, as they can hurt your business seriously. However, false positives are another story. They can be categorized as positive risk.
So on this slide, we want to show which variables from the feature engineering were important. In the bar chart, you can see the top 10 most important predictors based on the normalized betas. In our model, the activity and the NLP-based variables are the most relevant. The activity and the NLP variables like length of the comment and references in the comments decreases the churn too. The count of the comments since last 182 days decreases the churn the most. We want to make some sentiment analysis and topic modeling for more NLP-based variables, but unfortunately we didn't have enough resources to make it on the 2.5 years data.
So how can we use that in business? We have to create a churn prevention strategy. And for this purpose, we created this chart which shows what happens before churn takes place. You can see a decrease in interactivity before churn. You can get suspicious after one decrease, but you can, in fact, detect high-risk churners if that decrease continues for another month. And that is the prevention period. You have to intervene. You have to get your users engaged, send them personalized newsletters, or use some gamification so interaction increases again. Of course, our churn model can take into account a lot more factors. So our prediction is not only based on one, but a lot of other variables.